GPS has kind of become synonymous with location. And then I kind of wonder, well, now that we have all these new satellite systems up, we have, basically the GLONASS from Russia, Baidu from China, whether people in those particular countries refer to it as a Baidu in terms of location. But seriously, we're really thinking about the future of location and the technologies. And of course, location for us first came about as a result of GPS, Global Positioning System. And I was thinking back to the days when we didn't have it. And I remember trying to find my way to a particular venue, such as this hotel, not really knowing how to get there, driving around, circling streets, trying to figure it out. And then yesterday actually, when I drove up here, I just went to the navigation system on my car, punched in the address, and it led me right literally to the door where I turned in. So location is really a primary concern of ours, and it has been a primary concern for quite a long time. And just the little background, I don't know if you know much about CSR. We're about a 13-year-old company. We're located all around the globe. Headquarters is in Cambridge in the UK. Kind of an interesting connection with the previous session. There's a pub called the Eagle, which is located in Cambridge, where Crick and Watson in 1953 disclosed actually in this pub to the bartender's DNA. So that was kind of an interesting coincidence. I've actually had a pint of ale in that pub. And so the company got started doing Bluetooth technology back about 13 years ago, and was the first company to do single chip Bluetooth, which became very popular in mobile phones and automobiles, et cetera. And through the course of years, we've done some M&A activities. We're at about 2,200 people globally and about $1 billion worth of revenue. Kind of a small semiconductor player, so to speak, in the industry. We have 5 major business areas that we work in. Voice and music is really around the headset technologies now, which are growing tremendously. I know that we have representation here from Plantronics. The automotive, I think we realize both on the location as well as in the connectivity piece, the importance in vehicle. We acquired a company which does imaging technology, and then Bluetooth Smart, as it's called, is kind of an interesting new technology which actually at dinner last night we were having an interesting conversation about how Bluetooth Smart will revolutionize the industry in so many different ways. And it is part of my talk because actually you can use Bluetooth Smart beacons as a way of impacting location. And then finally, a kind of traditional location business which started out doing GPS chips and kind of has evolved into some of the things I'm going to speak about here today. Well, I want to give some acknowledgement to Dave Huntingford. He's one of my colleagues here in CSR, and he was actually the one that put together this slide, which I thought kind of helped give us some historical perspective or background on location. And imagine it's in the early 1700s. The British shipping industry is really gaining a significant amount of momentum, and you're wanting to sail across the Atlantic Ocean and end up, say, somewhere in the West Indies, and you're off by 100 kilometers when you get where you need to go. It's virtually it's a huge problem with being able to get from point A to point B, and so what the British government did was they put forth a contest and said anybody who could come up with a technique that would improve dramatically the ability to determine location when crossing the Atlantic Ocean could win a prize of 20,000 pounds. And as it turned out, John Harrison took that challenge. He was a clockmaker, and he produced that H1, which is shown there, which was able to fairly accurately keep track of time as ships sailed across the Atlantic Ocean and able to determine the longitude once you got to the other end. We looked at improving basically from 100 kilometers down to about 10 kilometers. And he continued to refine the technique. The H4, which looks a little bit like a pocket watch, but I'm told is actually about 5 inches in diameter, so it's not as small as a pocket watch, and now currently sits in a museum in London, turned into the first real kind of commercial deployment of the technology in the shipping industry. Poor John Harrison had to live practically his whole life. I don't think he collected his 20,000 pounds until he was probably close to 80 years old. But we've been dealing with this problem of location, literally for hundreds of years. And the military-sponsored system was put up, back some 30, 40 years ago, global positioning system. And it was interesting to talk to the guys at Boeing that were really involved in doing this, and it was really, a tremendous innovation. And for years, it was really just something that the military used. There were a few companies out there that did work in this space and produced the receivers capable of doing position fixing. They were on the order of, say, like $100, I think even more expensive when they first come out, about $1,000. And then we saw the commercialization of GPS. And even today, if you look at how much we use GPS, we just take it for granted. It's just part of it. It's in every smartphone that we have. It's been commoditized. If you were to buy a GPS chip today, it would cost you probably less than $1 US. The real challenge now is indoors. We spend 80% of our lives indoors, and in large buildings, we're literally in kind of the same situation that we were back years ago outdoors. And so it's the new thing with respect to how do you solve the problem of where you are and its relevance relative to what you care about. Just a little background on GPS. What I'm showing here is literally kind of what's the signal strength. You've got a bunch of satellites which are going in geosynchronous orbit. There's a certain signal strength which reaches the Earth from the signals that are transmitted. They're transmitting these PN sequences, and then use it and triangulate to figure out your position. Well, those signals actually don't penetrate very well indoors. And what I'm trying to show here in this graph, is literally kind of as how well they penetrate indoors relative to different types of buildings. Back maybe about 10, 15 years ago, we started working on ways of being able to enhance the performance of GPS by using cellular networks. And so you may have heard the term, AGPS or assisted GPS, which is now turned into assisted GNSS. And this is a pretty simple concept. If you've got all these cell towers which are located around the globe, you can literally reduce the uncertainty about where your location is. The very first GPS-based systems, and I remember going out and buying a personal navigation device when they first came out, and it cost me about $800, which I think they sell for $50 to $100 now. It took literally minutes for it to be able to determine my position because it was doing this very exhaustive search trying to figure out my triangulated position. Well, with assisted GPS, because the uncertainty of where you're located is much, much less, they can do a much more detailed search, and that's why you see that for AGPS, there's an enhancement in terms of the actual performance of the GPS system. And it's interesting because as we've done some testing of the performance of our assisted GPS chips, we can actually, in fact, get some position fixes indoors. We've done some of this in malls, shopping malls, et cetera. But in general, as we look, GPS systems kind of run out of gas as you try to go indoors, and particularly as we say, deep indoors. We wouldn't be able, for example, with pretty high certainty, would not be able to get a position fix inside of this particular building in this particular room. If we look at indoor location, there's two approaches so far that have been largely attempted. And if we look at the left, you can go into a particular environment, and we've got Bob who's here. He's going to chair the panel discussion afterwards. And Cisco did some very early work using their Wi-Fi as a means for doing position fix indoors. And it's kind of a simple concept. You've got all these Wi-Fi access points which are deployed in an enterprise environment. You can actually use those Wi-Fi access points and transmit signals from those access points, which will allow you to be able to do a position fix inside of a building. Another technology which is now emerging as well is Bluetooth Low Energy. And you can use Bluetooth Low Energy beacons. Some of you may have heard of iBeacon. You can take these particular kinds of beacons and deploy them in a building and use them also as say, kind of an infrastructure for doing position fixes indoors. You've also seen that there are companies that are not relying upon existing infrastructure. And some of the earlier ones were like Skyhook, which what they did was they went and they surveyed existing Wi-Fi access points which were located in buildings. Google has done a lot of this kind of work as well. You may have seen the Google truck driving around in your neighborhood or through your office park. And essentially, they're collecting the MAC addresses for the Wi-Fi access points and putting them in a database. The problem with this approach is that it's highly inaccurate, because what they're doing is essentially taking the fix of what the location is outdoors, and then if they were to scan a building and pick up 10 access points, they would just stick that associated with the outdoor positioning. And there's some interesting things that we've seen we're usually at the Consumer Electronics Show that's in Las Vegas, and I was there in the South Hall, and we were looking at the position fix that was coming from Google. And actually, because some of the companies had moved their access points from their corporate headquarters into the South Hall there at the Consumer Electronics Show, it would say that your location was actually, say, in like San Diego instead of in Las Vegas. So Wi-Fi has kind of been the first technology which has been used, but you can also use cell tower information, et cetera.